A very good morning, dear students. Welcome to today's physics class. We are dealing with the unit gravitation. In the gravitation, we have seen what is force of gravitation, universal law of gravitation, the force between two objects under the gravitational force, uh, acceleration due to gravity on a freely falling object, mass and weight. These are the important topics that we have seen in this unit. And the second part of this unit uh, deals with thrust, pressure, buoyancy, Archimedes principle, and density. But to your luck, these things are not for the terminal examinations, not as a part of the syllabus. These things are there, but not part of the syllabus. But I would like to say these are like what we studied: force, velocity, acceleration, mass, gravity, and weight. Like those fundamental concepts, these are also very important fundamental concepts in physics. What is thrust? What is thrust and what is pressure? uh, you may why if you think some of the questions of why, you will understand what does it mean. Why does it weighs more when you carry a school bag of thin strips? If you have broad strips, you may feel less weight. Why it is? Why the thumb pins? Why it is easy to pin the thumb pins on the notice board but not on the blunt pins? Why the cutting tools like knives or drilling machine, why do have they have the sharp edges? Why? That those are some of the questions, like why the camel travels fast in the desert. When you walk on the beach, your leg goes down when you walk on the beach, but when you lie down, when your body goes will the body goes down? Why? Why? And why does when you put something on the water comes out, it displaces something? What is the density? So these are some of the basic questions that you should ask yourself. Okay, why does you put a plastic ball or a rubber ball inside the water? You pull it, you push it down, it will come up. Why? Why? Why when you throw a nail or a stone on the bowl of water or a container of water, it will go down. But when you throw a paper, it doesn't go down. Why? So these are very basic examples of everyday life, right? These are not any alien thoughts, but these are very basic concepts that we face daily. When you go to the kitchen, the knife is very sharp. Why? Why the sharp knives cuts fast? You apply less force. For the blunt knives, you have to give more force. So what is force? What is pressure? What is thrust? What is upward movement? Why doesn't a huge ship made of iron does not sink into the sea? You should ask why questions. Why this is happening in our day-to-day life. So, for a good news, these topics are not for a part of your syllabus for this year, but I would like all of you to read the second part of this unit when you come to the Zoom class. I will give, uh, I will teach you these things, though it is not part of the syllabus. I will teach you these things, but not in this class because I want to interact and teach. Okay, when you come to Zoom class, I will teach all these concepts. These are very important concepts. Density, okay, density, force, pressure, thrust, All these things are important, so we will do in the class. Now, today we are going to see some of the problems, some of the numericals that is connected to gravitation. I will solve 3 or 4 questions today, and I will give some questions as a homework. You can do it at home. And one thing, I'm really disappointed. Some 7 to 8 students have done this weekly assessment. I'm going to take serious action against you because you people are not doing any. Out of 23 students, only 7 to 8 have done the science weekly test that was conducted on last Saturday. I'm going to give the future questions only to those students, not to others. Okay, but today we shall go and do some numericals on this unit. This is one of the basic problems that we are going to see today. Calculate the force of gravitation between two objects of mass 50 kilogram and 100 kilogram when they are kept at a distance of 10 meter apart. Very easy, damn easy problem. You know the force of gravitation F is equal to capital G universal constant m small m into capital M divided by d square. Okay, this is the formula of the force between two objects under the influence of gravitation. What is G? 6.67 into 10 to the power minus 11 into 50 gram into 120 kilogram divided by 10 square is 100. 10 into 10, that means 6.67 into 10 to the power minus 11 into 5 into 12, 60, 6000 divided by 100. When you cancel, the value is F is equal to 40.2 into 10 to the power minus 9 Newton. Okay, this is the force of gravitation between two objects under the influence of gravitation. Let me know the second problem. Okay, we are going to solve the second problem, that is from the equations of motions. You already know u is equal to v plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. You know all the problem, all the 3 equations. How these equations of motion is affecting the vertical motion or motion due to gravity. I have already said, for any object, this is a thumb rule. Like, what is a thumb rule? When an object is thrown upwards, u is the initial velocity is not equal to 0, because if the initial velocity is 0, you cannot throw a ball or a stone upwards. So there is some, it is greater than 0, there is some value. Okay, it is not equal to 0. That is for any object that is thrown upwards. Okay, g is acceleration due to gravity is always minus 9.8 because it is going against gravity. Velocity is against the gravity, so 9.8 meter per second square. This is a thumb rule. Like, now then what is 0? At when you throw something upward, it will go and reach the maximum height. At that point, the velocity is 0 at that point. So v is always 0. Okay, for any object that is thrown upwards. Okay, this is a rule. What is the rule? The initial velocity is not equal to 0, but the final velocity is 0. Okay, now when something is thrown from up from from top to bottom, okay, when something ball is coming from the top to bottom, in that case it is towards the force of gravity, so G is 9.8 meter per second square. So what is U when it is dropped? When a stone or ball is dropped, at that moment U is 0. The initial velocity is 0. We have to find final velocity. So these are two different things. When a body, a ball, a stone are thrown upwards, V is 0, U is not 0. But when something is dropped from top to bottom, U is 0, V is not equal to 0. These two things you have to keep in mind. And other things are damn easy. You see, a piece of stone is thrown upwards. So this one, okay, thrown upwards. I have already said vertically upwards. It reaches the maximum height in 3 seconds. So T is given. T is equal to 3 seconds. Okay. Calculate the initial velocity. Simple. I have said three formulas. These three formulas, where will the T come? If you have attended my Zoom class, you know first equation. In the first equation, there is T. So we have to put the first equation. You might get confused, no? How, what to use? Oh, there are three equations. So what equation to use? First equation, because T is given. For example, V is equal to U plus AT. S is equal to UT plus of AT square. Um, V square minus U square is equal to 2AS. Okay. Here in this unit, instead of S we will use H, height. Okay. S is the displacement. Okay, in the horizontal motion. But in the vertical motion it is height. That's all. So where is T? T is in the first and second equation. We can use first equation. Okay. Because we have to find initial velocity. Final velocity we know. At that point the final velocity is 0. It reaches in 3 seconds, it reaches the maximum height. After that it comes down. So at the maximum height the final velocity is 0. So we can solve the problem. That is easy, no? V is equal to U plus AT. So instead of A we will use G. Okay. Why we are using G is acceleration due to gravity. Okay. And acceleration due to gravity, we are throwing against the gravitation, so it is minus 9.8. What is U? We have to find U. Okay. What is V? V is equal to 0. U plus minus 9.8 into T. What is T? 3 seconds. That's all. Okay. Now put it on the other side. U is equal to, probably, if you calculate 10, 30. So but the correct value is 29.7, 29.4 meter per second. Okay. Meter per second square. Simple. We have not done anything. We just put those values here. We have not done anything extraordinary. We just wrote the formulas and substituted the values. That's all. Okay. That's all. Over. Now we shall do something on the other side, on the ball or a stone that is moving from downward. You see, this is another very practical problem. Very practical problem. This is not something very high. You see, a stone falls from the building. Okay, this is a building. So it is a building. Consider this is a building. Okay, a stone falls from a building and reaches the ground in 2.5 seconds. In 2.5 seconds. Okay, T is equal to 2.5. What is the height of the building? You see, simple, very practical. A stone is dropped from a building and it reaches the ground at 2.5 seconds. So the time is given. What is the height of the building? If you have to solve this very basic ordinary problem that is applicable to our daily life, you need these equations of motion. Okay. what they ask, height of the building. Height of the building means yes, right? Height of the building means yes. Yes, but here it is h. Okay, how the stone is displaced from this point to this point. So it is displacement, but in the unit of gravitation we use s as h. Both are same. Now you see, first equation, v is equal to u plus at. Okay, the time is given, but they asked final velocity. Now here the same, time is given, but what they are asking, they are not asking final velocity, but they are asking height of the building. So when they ask final velocity, you use the first equation, v is equal to u plus at, right? When they ask uh, height of the building, s is equal to h. S and h are one and the same. Okay, h is equal to ut plus half at square. That's all, done. Ut plus half at square. I have already said, go back to this video and see, when something is dropped from high, okay, when it is a downward movement, what is u? What is u? Initial velocity. Initial velocity is 0, because at the time of dropping the velocity is 0. Okay, that's all. We can put h is equal to ut plus half at square. So what is a? A is g. Okay, acceleration due to gravity. When it is dropped down, it is towards the force of gravitation. So g is 9.8, irrespective of mass. Whatever be the mass, any object that is dropped on the earth, the acceleration due to gravity is 9.8 meter per second. Now u is 0, so this value is 0. Half g is 9.8 into t square. What is t? 2.5 into 2.5. That's all. 4.9. 4.9 into 2.5 into 2.5. The value is 36 point, sorry, 30.625, I think. Okay, 30.625. Simple. S or h, both are one and the same. H is height, s is displacement. Simple. The formula looks very tough, but when you apply, it is very simple. So don't worry about the problems. We shall do the third one now. Now we are going to solve the final problem of today's class. The same concepts, not very difficult. Okay, a stone is thrown upwards. Stone is thrown vertically upwards with the speed. So initial velocity is given, u is equal to 20 meter per second. Okay, when it's thrown upward with the initial velocity, how high it will go before it begins to fall. That means what is that? They are asking h. Simple, they are asking h. So you know, a body, a stone or a ball or any object that is thrown from downward to upward, what is g? G is equal to minus 9.8 meter per second square. Okay, that's all. What is the another thing? V is equal to 0. How high will it go before it began to fall? That means they are asking height. Final velocity is always 0. Fine. That's all. Which formula will you use? Because time is not given. If time is given, we will use the second formula. Remember? Remember the second formula? What is the second formula? V is equal to u plus at. S is equal to ut plus half at square. Now here comes the application. Like, there are three formulas. Which formulas to use? You may get confused. No, it's not. You need not to get confused at all. We have solved the same problem before. There t is given, time is given, and they asked for height, s or h. Okay. So when they give time, use the second formula. When they give the value, velocity, initial velocity, you use the third formula. What is the third formula? V square minus u square is equal to 2gh. 2as is 2gh. That's all. but it's simple. You put the value. So when you know whatever is the problem, when t is given, time is given, you use first or second equation. Okay. When time is not given, you use the third equation. That's all. That's all. Okay. V square minus u square is equal to what is v square? Already we know 0 square. What is u square? U is minus 20 square. Okay. 20 square is equal to 2. What is g? Minus 9.8 into what is h? H only we have to find. Okay. H only we have to find. 400 minus 400 into 9.8. Okay, if we roughly calculate, roughly if we take, it is 10. Okay, instead of 9.8, if we take 10 minus 20 into h, okay, then h is equal to 20 meters. That's all. Okay, 20 divided by 400 divided by 20, 20 meters. That's all. So we have solved uh, three problems for 3 equations. That's all. I hope I have done these problems even in the first unit, force, and here also we are doing. So now you will get a clarity of how to use these equations of motion in our daily practical life. Okay, simple. When a ball is thrown upwards, it is thrown with this velocity. What is the height? So this is the height. What is the final velocity? And what time it will reach the ground? So these are very practical things that we deal with our day-to-day life. So before you come to the Zoom class, I would ask all of you to read and come the pages like 138, from the page 138, thrust and pressure, Archimedes principle, buoyancy, and density, relative density. All those 5 concepts I will teach you in the Zoom class, not in this video class, but because I need some interaction, that we will do that. Hope you will do well. All the best. Do well. Thank you.